Good day. So we're still looking at questions from the 2025 November paper, paper 2. And in this case, we have a circle. So this is a circle, and let's first analyze and see what we can figure out from the circle. So read the information. PQRS is a cyclic quad. T is a point on the circle such that QT is perpendicular. So important words, perpendicular to SR at V. PT and ST are drawn. Q2 is 35 and R1 is equal to S1. Okay. R is equal to S1. So those two are equal. R and S1. And then we're also given it's a cyclic quad, so PQRS, but we already see it's a cyclic quad because it's inside the circle and all of its points are touching the circumference of the circle. Therefore, it's a cyclic quad. And we're given that that's 35. So let's try and work out other angles that we can. So we know that's 90. Those are both on a straight line. Subtract from 35, we get 180 minus 35 minus 90 to get angle R, because those two are in triangle VQR. So that's 55. That's also 55. Also 55. And what else can we work out? It seems like definitely it's a harder question. So we are given, so all of those will be 90. So a revolution, that'll be a point is 360. So that's a full revolution. Let me erase this. So what other angle can we figure out? We can figure out this angle here. So P and S are in a cyclic quad. That means they'll sum up to 180. So I have 180 minus 55 minus 35. And then that angle will be 90. So that angle is a 90. So let me erase. So far we've figured out 35, 55, 55, and 90. Let's see what else we can figure out. R and S, perpendicular cyclic quad, triangle. We don't have angles of the same segment, but I guess we do. So let's highlight that. So if angles on the same segment over here, highlighted in yellow. So angles on the same segment over there, highlighted in yellow. And then therefore, we have another 35 over here. So that's also 35. And this whole angle here will be 55. And that's that on that. That's all we can find so far. Have those two angles that won't help us much. So 35 plus 55. This doesn't give us 90, so we can actually mark that as 90. So this is also 90. So this is actually a diameter because it's cutting the circle and then we get a 90 on the circumference. So that's a diameter PT. And that's all we can find for now. I would say, yeah, that's all we can find for now. Let's see what the questions are asking us, but this is definitely a much harder example. The first question says, find QTS. Let's go up. QTS, QT, is that whole angle. So find QTS. So already mark that whole angle in purple. So you need to tell the story of how you got to that angle being 55. So you'll first say R2 will be 90 because these two are on a straight line. Or on an R2 or 90 on a straight line. Then you can find 55. You find 55. After finding the 55, you can just claim angles in the same segment. So angles in the same segment, therefore QTS is 55 because of angles in the same segment. So we can actually find this angle here. We can find the angle P because we look at the cyclic quad PQT. We can find that angle. We can say 180 minus 55. That's 125. That's because of angles in the cyclic quad. That's 125. That's not really helpful because you want P1 and P2 individually, not the whole sum. So that's the first question. Angles in the same segment. Then they want us to prove PQ is parallel to SR. So PQ parallel to SR. So here, PQ and SR. So the only way to go here would be to look at co-interior angles because there are no transversals. There are no lines that are crossing those parallel lines to cause alternate angles. So thinking about fun X, the only way that we can prove those two lines are parallel is by using the U. So the U, those are your co-interior angles. So it's very difficult to remember all of the reasons, but you have to study the different reasons. And these are from grade 8. So PQ and SR, let me mark them as parallel actually. So if I want to prove them as parallel, then I'll look at the U. Look at the U. So looking at the U, I have this U over here. And I already have sort of shown that those two add up to 180. So I just need to tell the story. So I need to show that S1 and P add up to 180. And do I have that information? The answer is yes. I just need to tell the story of how I got there. So I'll say, now that I know that this is 55 over here, from the previous question, QTS 55, QTS plus P gives me 180. Those are inner angles of a cyclic quad. Therefore, P is 125. I'll just label it the whole P. P is 125, and R1 equal S1 equals 55. That was given. Therefore, I can say, or rather R, not R1, R is S1. Those are both 55. Therefore, I can say the two lines are parallel because the co-interior angles are supplementary. So you are stating it in a converse way. You're saying because co-interior angle theorem is satisfied. So we'll say because P and S1 add up to 180, co-interior angles are supplementary or add up to 180. Therefore, PQ is parallel to SR. So it does use information from this question, which was the 55, 55. Then you use your cyclic quad to have the 125. Then you have the 55 from the given information. Then when you add the two, you get U. U is the only option here because we don't have a F, an N, or an X. An X is not parallel. These are the ones that are fun. We have parallel lines attached. So those are parallel. Those are parallel. Parallel. And the X is just vertically opposite angles. But fun X is important as we move on along. Okay, so that's that on that. We have to look at co-interior angles, or the U of fun X. It's important to really study all of your reasons. So now prove its diameter. So we've already spoken about this diameter briefly. Because the line PT cut and it created a 90 on both sides. So if you look at this, so here you want to prove that Q1 is 90. So is Q1 90? And the answer to that, it would be a clear yes. Is Q1 90? And also is S1 plus S2 90? So for some other reason, is it 90? And that other reason is the cyclic quad, which is why they want you to prove that it is a diameter. So to prove the parallel lines, you can actually say using the parallel lines, I'll have another co-interior angle for this Q1. So another co-interior angle. Then you'll say 55, 35. What's left? It's actually a 90. Or you could say opposite angles of a cyclic quad. This cyclic quad PQSR, the one that they gave us. Then we'll say 180 minus 35.